Okay, let's see if I can drive this. All right, as Bob mentioned, today I'll be talking to you guys about the management of marine megafauna as climate change progresses. So to start with, I'll be talking about some of the challenges that managers face in managing both turtles and dugongs in the future. And then I'll be describing some of the research that I'll be conducting the next 3 years to address these challenges. So some of the ideas that I'll be discussing to you guys today come from a project that I recently started with Bob Pressey and Helene March at the center. And the main goal of this project is to develop systematic priorities for the management of both turtles and dugongs in the northern Great Barrier Reef and Torres Strait region. So the northern Great Barrier Reef area and the Torres Strait region contains globally significant population of turtles and dugongs. As Terry mentioned yesterday, both turtle and dugongs have important ecological roles as they help maintain a healthy seagrass beds and also balance food webs. Turtle and dugongs are also extremely important for Indigenous Australians, as Indigenous Australians use turtle and dugongs for social gatherings and ceremonies and also as a food source. Further, sea turtles also have importance for the tourism industry, as tourists indicate that they place a high value on seeing sea turtles on the reef. Consequently, any depletion of the population of turtles and dugongs in the Torres Strait region will cause impacts to both the tourism industry and Indigenous Australians. So in the northern Great Barrier Reef and Torres Strait region, we find 3 populations of turtles. The first one is the northern Great Barrier Reef green turtle population, and this is actually the largest green turtle population in the world, with an average of 50,000 turtles nesting during a high nesting year. This population of turtles is particularly important, not only because they're herbivorous, but this population of turtles are the ones that are hunted by Indigenous Australians as a food source. As you can see on this map, this population nests on the islands in the northern Great Barrier Reef and also eastern islands in Torres Strait. Monitoring by Queensland Parks and Wildlife Service indicate that this population is experiencing a decrease in the rate of increase. And further monitoring also indicates low hatchling production at Rain Island, which is the main nesting site for this population. So what this means is that in the future we're going to start to see a reduction in the number of adult turtles in this population as a result of low hatchling production at Rain Island. The second population of turtles found in this region are the flatback turtles, and the flatback turtles are actually endemic to Australia. This particular population of flatback turtles nests on the western Torres Strait Islands and also mainland beaches on the Cape York Peninsula. Recent studies also indicate that this population is experiencing a decline. And the last population of turtles found in this region are the Hawksbill Turtles. And Hawksbill Turtles in this region are nesting in the central Torres Strait and also in islands in the northern Great Barrier Reef. And studies at Milman Island, which is the main nesting site for this population, indicates that they experienced a 4% decline in the population size during the last 10 years. So the Torres Strait region also contains a globally significant population of dugongs with an average of 23,000 to 29,000 dugongs in this population. So just for you to have an idea of the relative density of dugongs in Torres Strait, I have this map here that you can see that the relative density of dugongs in Torres Strait is a lot higher than the rest of Australia. As I mentioned before, dugongs are important for Indigenous Australians as they have the legal right to hunt dugongs as a food source. However, local information and modeling studies indicate that the hunting of dugongs in Torres Strait is not sustainable and they're being overharvested. And as you saw from Terry's presentation yesterday and David, the population of dugongs are actually declining also. So with all the predictions of changes in the northern Great Barrier Reef and Torres Strait region, it's likely that the habitat used by both turtles and dugongs will be impacted, and that climate change will also cause a direct impact on turtles and dugongs. So sea turtles are thought to be particularly vulnerable to climate change as they have life history traits tied to environmental temperatures. And it's likely that the most direct impacts of climate change to sea turtles will occur during the terrestrial reproductive phase, that is, when the eggs are incubating and at the nesting grounds. And this is because temperature plays a major role in sea turtles' embryo development, hatchling success, and hatchling sex ratio. So if you have a look at this figure here, you can see that in order for sea turtle eggs to successfully incubate, they have to incubate within a narrow thermal range that goes from 24 to 34 Celsius. So any temperature above or below this will cause the eggs not to develop and they'll die. In addition to this, sea turtles also have temperature-dependent sex determination, and this means that the sex of their hatchlings is determined by the sand temperature while they're being incubated. So warmer temperature produce more females, and cooler temperature produce more males. So it's expected that as climate change progresses, the nesting grounds that are currently cooler will start to reach warmer temperatures and will be producing more females, potentially causing a feminization of turtle populations. And nesting grounds that are already warmer and producing more females will be reaching the upper thermal incubation threshold more often, potentially causing a decrease in hatchling success. Indeed, some of the studies that I have conducted were investigated the impacts of climate change on sea turtles. I found that for the northern Great Barrier Reef green turtle population, as climate change progresses, most of the nesting grounds will be producing females. And if they don't adapt to climate change, most likely they'll experience a feminization of their populations. Further impacts to sea turtles can be caused by sea level rise through inundation of nesting beaches. And some of the early research that I conducted, I estimated that up to 34% of the nesting grounds used by the northern Great Barrier Reef green turtle population might be inundated by 2070. Further impacts to sea turtles can also be caused by cyclonic activity and storm events, and this will impact nesting grounds morphology and stability, also reducing the reproductive output of turtles. So just to exemplify this, I have a picture here. Whoops. Back. All right, so in this picture here, I don't know if you can see well in the back, but basically you can see some turtle eggs exposed here. And this was caused after big storm surges in Torres Strait. So basically with more extreme cyclonic event and storm surges, we're going to start to see more nests being exposed and ended up dying. So further impacts to turtles can also be caused through changes in ocean currents, which will likely cause changes in the distributional range of juveniles and also hatchling dispersal. Turtles will also suffer impacts from climate change through indirect impacts on their food source. Unfortunately, not as much is known about the impacts of climate change on dugongs. However, it's unlikely that increased sea surface temperature will affect dugong distributions, as dugong distributions is often linked to cooler water temperatures. So sometimes we find dugongs in waters with temperatures up to 36 Celsius. So if anything, with increasing sea surface temperatures, it's likely that we're going to start to see dugongs with a broader range of distribution. The only problem with that is that if dugongs start using areas that have more threats or at places that management are logistically difficult. One thing that increasing sea surface temperature and extreme events will cause is impacts to seagrass, which is the main food source for dugongs. Seagrass diebacks are linked with increasing dugong mortality and reproduction and breeding. So basically, dugongs will likely experience indirect impacts through impacts on their food source. So the resilience of both turtle and dugongs to climate change is already compromised by a reduction in the population size during the last decades. And some of the anthropogenic threats that both turtles and dugongs have experienced in Torres Strait and the northern Great Barrier Reef include unsustainable hunting by indigenous Australians. And as I mentioned before, both turtle and dugongs are used as a food source by indigenous Australians. Some studies indicate that up to 60,000 green turtles have been taken a year as a food source in Australia. We still don't know how many dugongs are taken a year, but the good news is that some of the monitoring programs by rangers in Torres Strait are starting to more closely monitor the number of turtle and dugongs that are taken each year to provide information for the sustainable management of these resources. Even though hawksbill turtles are not harvested for their meat, they're harvested for the shells because they have beautiful shells that are used to make crafts and also jewelry. Some of the impacts that the flatback turtles experience is predation of the eggs by introduced species. So in some areas in Cape York, you find that 90% of the eggs laid by flatback turtles are predated by feral pigs. Further impacts to both turtles and dugongs are caused by boat strike, pollution, and bycatch. However, no study to date has quantified the mortality of turtle and dugongs to these activities, so we don't know the relative risk that these activities cause to both turtles and dugongs in the Torres Strait and the northern Great Barrier Reef region. So just looking at this, you can see that both turtles and dugongs are faced with a variety of impacts, and that climate change will likely cause further stresses to these populations. So managers are facing the challenging of addressing the direct effects of climate change to both turtles and dugongs, as well as the current threats that they're facing. However, for logistical and financial and political reasons, managers cannot address all of these impacts. So they must prioritize which threats they're going to mitigate and how they're going to allocate their limited resources and funding. So considering this, there's different studies and management agencies have started to develop a framework to be prioritizing the management of turtles and dugongs. However, the majority of these frameworks, they assume a static environment. And this approach is not realistic considering the predicted changes in the environment. So there's a need of a systematic decision theory framework that accounts for the benefits and costs of actions while also accounting for the impacts of climate change. So considering this, the aim of the research that I'm conducting right now will be to develop such a framework for the turtles and dugongs in the northern Great Barrier Reef and Torres Strait region. So the first thing that I'll do is to identify the current threats and the future threats to these populations. And then the aim of that is to be identifying different management strategies that can be used to mitigate those threats. After I identify the different management strategies that can be used to mitigate these threats, I'll be screening their feasibility, costs, constraints, and opportunities. So all this information will be put into a systematic decision theory framework to investigate the efficiency of different management strategies. And the efficiency of different management strategies will be described as a function of the benefit of a specific management strategy, so in relation to the benefit that it brings to the population growth. And for this, we're going to use demographic population models. We're also going to look at the probability of a specific management strategy being successful. And for this, we're going to be looking at the opportunity and constraints involved in implementing a specific management action. And all of this will be investigated in relation to the costs. This will aid the prioritization of limited conservation funds to specific threats, and also for managers to achieve the greatest benefit to conservation of biodiversity as climate change progresses. One of the interesting things about this framework is that it will allow us to compare the efficiency of different management strategies. So for example, we'll be able to compare the efficiency of using adaptive strategies versus using strategies that are looking to enhance the resilience of populations. We will also be able to compare the efficiency of different management strategies and how they vary at a temporal scale and at a spatial scale. So at this stage, I have already started to look at the feasibility and benefits and risks of different management strategies to mitigate the impacts of climate change to sea turtles. However, today I don't have a lot of time to go through each of the management strategies that have been identified. So if anyone wants to have a closer look at this information, please feel free to contact me. But one thing that we have noticed is that the success of different management strategies will be dependent on the climatic impact and also on the socioeconomic and cultural conditions at a particular place. So management strategies have to be considered at a regional scale. Another thing that we have identified is that there's a lack of knowledge on the feasibility and effectiveness of identified management strategy, making it very challenging to be implementing any of these strategies. Further challenges on implementing different management strategies come from lack of biological data to help direct decision makers. And this goes back to what Joan was talking yesterday about the lack of historical and baseline data impacting the implementation of different management strategies. So, for example, the main concern that we have with increasing temperature to sea turtles is that it will cause a feminization of turtle populations. So there's a variety of different management strategies that have been identified to mitigate the impacts of increasing temperature to sea turtles. And some of the strategies you can see here, they go from revegetation, artificially incubating eggs, and also nest shading. However, we still don't have an understanding of the current hatchling-sex ratio from which to measure future climatic-related changes, or knowledge of how many males are necessary to maintain a fertile population of turtles. So, at the moment, we can't really implement any of these management strategies. So, this only highlights what David was talking today about the need of targeted research to aid the management of species in the future to climate change. So in the meantime, while we're collecting more information on different management strategies, I would say that there's a need to reduce carbon emissions and also to mitigate the negative pressures that both turtles and dugongs are experiencing in order to increase their resilience and also their capacity to adapt to climate change. So for a population of turtles and dugongs in the Northern Great Barrier Reef and Torres Strait region, this means ensuring that hunting is sustainable, protecting key habitat of turtle and dugongs, enforcing legislation, and also reducing pollution. And all this can be achieved through environmental education. However, as climate change becomes more extreme and the impacts of climate change become more visible, it's likely that we're going to have to use more active management strategies. Considering this, studies such as this one will become more and more important in the future to help managers prioritize their decisions. Thank you.